Well, hi everybody. Thank you very much for joining us today. We are very excited to introduce a new use case built on top of RSK and RIF that is about the nuclear industry with Nuclearis that did the development. Today we have with us Santiago Badran, the Nuclearis CEO, and also Sebastian Martinez, Nuclearis CTO, that they're gonna tell us about this solution for the nuclear industry. Thank you, Sebastian, Santiago, for joining us, and let's get rolling.
Okay. Hello. My name is Santiago Badran. I am mechanical engineer. I am the founder of this company called Nuclearis. I have worked for 10 years in the company that produces the uranium fuels in Argentina. And then, after that, in 2009, I founded Nuclearis together with my partner Damian Torre, who, this is me, this is my partner Damian Torre. He's specialized in quality assurance, and Damian is a Nuclearis founder too. But we are not only men, we have a woman as general manager, and I am very proud to see a woman leading a nuclear company. She is Maria Jose Ureta. Okay, what do we do? Nuclearis is a company that is specialized in the engineering of nuclear reactors. We make basic and detailed engineering for nuclear reactors, and two, we are dedicated to the manufacturing of special components. I am talking about mechanical components for the core of the nuclear reactor. In Argentina, there are 3 NPPs, and currently my country is constructing a new kind of reactor called SMR, Small Modular Reactor. This is a very disruptive concept, and Nuclearis is working for this project too. Regarding our story, it is funny. This is very funny. I am proud to tell you that we started in a garage. I am not Steve Jobs, but really we started in a garage. But I don't want to bore you with my entrepreneur story, but I have to tell you that we started designing and building a machine, a special machine, to produce a critical mechanical part for the functioning of 2 NPPs in my country. NPP is nuclear power plant, and these 2 NPPs are Atucha 1 and Atucha 2. And at that moment, we use, I am talking about 10 years ago, at that moment, we use all our savings, all our money, and we worked for more than a year to make it real, to build a machine. We didn't know if it would work. But finally, the machine worked very well. We won our first tender in 2010, and from that moment, Nuclearis started growing until today. Okay. Later, we developed many other mechanical special components, and we started to make engineering of nuclear reactors. And now we are still here. we are still here. We are taking new risk, investing. We are investing in a disrupting technology called blockchain. Uh, but it's a technology blockchain applied to the nuclear industry. Okay, I think that I will show you our production plant. This is our production plant in Argentina, in Buenos Aires. This is our offices in Bariloche, in the Patagonia of Argentina. We opened a new company called Nuclearis Corporation, located in United States, specifically in Albuquerque, in Nuevo Mexico. And the last year, we opened commercial offices in Shanghai, in China. And I am talking to you about nuclear reactors or Nuclearis story or mechanical parts, but I guess you are thinking, what is the nuclear energy? How does it work? And I will explain very, very simple. The answer is very easy because you can visualize an MPP, a nuclear power plant, as a big machine to harvest electricity. You know, we need electricity, of course. And to produce electricity, you have to set in motion a big generator. A big generator is like a big engine, and you have to set in motion the generator. You have to rotate its shaft, the shaft of the generator, connecting it with the shaft of a steam turbine. The steam, you have the steam turbine, the generator, and this is the way to produce electricity. This is the main way through which the human being produces electricity. Now you have to move this turbine. You have to move this turbine. You have to create steam. And what can you do to create steam? To make it simple, you have two ways. Basically, you can heat water burning a fossil fuel. Imagine a big vessel with water, and you need to heat this vessel burning through a combustion. Yes, but this combustion produces ton of carbon dioxide that contaminate the air that we breathe. The other way is to create steam by heating the water through a controlled chain fission reaction. And this is a nuclear power plant. This is the steam. This is a nuclear reactor. Okay. And if you split some uranium atoms, you will obtain the magic of the nature, because the result is an enormous amount of heat without carbon dioxide release. This is the nuclear magic. When I talk about turbine, steam turbine, this is how it looks. It's a very big machine, okay? This is inside an MPP. And when I talk about a nuclear power plant, this is how it looks. It's a beautiful and clean machine to harvest electricity. Of course, you can to produce electricity by a conventional energy. You can to burn a fossil fuel, but I recommend it about the contamination. This is how it looks, a conventional energy. A conventional plant, of course, a carbon plant. Okay. Now, I am talking about energy and nuclear energy, and what you are thinking, what is the relationship? What is the relation between nuclear technology and blockchain technology? Regarding that, I can assure you that if you are the operator of a nuclear reactor, your biggest wish in your life is that the reactor never fails. Okay. And the way to minimize the risk of the failure is to use mechanical parts that were produced under an exhaustive nuclear regulation and under an effective quality system. This is the way to obtain the reliability of the reactor. And I will say, if you can ensure the quality in every single individual mechanical part of a nuclear reactor, you will ensure the reliability of the entire set, you know. La siguiente. Wait. Now I have to going back to our story. This is our first machine that we design and we construct in Nuclearis, and this machine is used to produce a special part, a very special critical part to seal. This is the seal ring. This part is to seal the primary circuit inside the core of the nuclear reactor. This is a very critical part. Nuclearis has been producing thousands of these seal rings for the last 10 years. But this year, at this moment, we are producing 2,000 pieces, new pieces, because this part is consumable that use these two nuclear power plants in Argentina. This year, at this moment, we are producing the first batch under blockchain, and this is the achievement, our achievement. We are the first company in the world that produced a mechanical component for the nuclear industry, authenticated through blockchain. Okay, I am proud about that. To explain that, I would like to introduce Sebastian Martinez. Sebastian.
Santiago, thank you very much for this great introduction. I sure think that every one of you now understands a little bit better the nuclear energy and what goes on inside a nuclear reactor. Well, I'm Sebastian Martinez. I'm a mechanical engineer like Santiago. From early years on, I named myself a self-taught programmer, developer, since I started working with web pages, platforms, and everything involved with development of things of the internet. And when in 2017 Santiago encountered me here at work with the idea of implementing blockchain as a technology in the traceability of documents, I was very eager to start working with this technology, this unknown technology for me. And so, like one says, I went down the rabbit hole inside the blockchain, which is a never-ending universe of things. And talking about Nuclearis, I'm now 5 years here at Nuclearis, and as Santiago, I hope, made the appearance, we are always striving for new technologies and new challenges. So back to the question Santiago proposed a little bit earlier, what is blockchain? I will do a very brief introduction for the people who never heard of the term blockchain. Please bear with me, the people who have lots of experience in blockchain, since it will be really oversimplified and doesn't respect all the principles and concepts of what blockchain means. Well, starting in the year 1879, Thomas Edison invented the light bulb, and with that, electricity came inside our houses. You have to imagine this as layers covering our beautiful planet and bringing us different technologies. For example, electricity was first used as a light bulb, but the houses were not electrified before the light bulb, but the light bulb was a cause to electrify houses. Then, on top of the electricity in the 1980s, ARPANET was created by us, and this gave the start to what today is known as Internet, and we're using it right now for this nice presentation. And then on top of this layer, the Internet, in 2008, a group or a person named Satoshi Nakamoto used the distributed ledger technology, what's known as blockchain, as a way for Bitcoin. Eventually you heard about the term, the first used cryptocurrency. But we will not dive into cryptocurrencies. This is just about the blockchain technology. So back to the question, what is blockchain? Blockchain is a decentralized network of participants, nodes, you can imagine computers and other servers and stuff like that, who is connected like a network, there's a network, and it keeps updating itself all the time, almost instantaneously, so that every participant has the same version of this chain. And the information one uploads to the blockchain cannot be modified or altered. It is immutable, as one can say. Well, why we need traceability? You may ask. Why don't you use a database or some other way for this whole thing to work? Well, the importance of the documentation in the nuclear industry is very, very important, very critical, because each document which gets placed inside a nuclear generator has to present all the documentation which is generated across all the processes the component goes through, starting with the mining of the material, prime material, through the machining and other processes that gets added to this component. A component without documentation has no value inside the nuclear industry. If you lose the documentation, if you can't back up the component with documentation, you can also throw it in the garbage, in the trash, because it has no value. So one has always to provide documentation with each screw, with each seal you supply to a nuclear power plant. And this comes to this quote that which Santiago, I think, already said, ensuring the quality of every component that gets delivered to the nuclear power plant ensures and guarantees the reliability of the whole nuclear power plant. So there is a joke known around in the nuclear industry that sounds like this: a nuclear power plant, when they receive a component which they place inside their power plant, comes inside a pickup truck, like, let's say that a little car. But the documentation that follows this pickup truck is a heavy-sized truck. So you can get here the feeling, the difference between what is a component and what is the size of the documentation backing up said said component. Sorry. Well, now you may think that this whole documentation which gets shipped with the component, is it reliable? I mean, you have a foundry which creates the material, places providers who supply machining processes and a whole plethora of things. You have to think, yes, this documentation should be reliable because it is very critical for the nuclear power plant if they want to place this component inside their plant. But I have to tell you that this is not the case. I mean, in the majority of times it works fine because of blind trust. But as you can see here, there are events, they happened in France and here in South Korea, where there were foundries who created components for nuclear power plants, and later on they were investigated by state prosecutors because of forgery or alteration of said documents backing up a component which finally goes inside a nuclear power plant. And this is also not a case just with here in France and in South Korea. Even the IAEA, the International Organization for Nuclear Energy, has a technical report talking about how to manage these items. So it is a problem inside the nuclear industry which has no solution until now. Well, now after talking plenty about why is it important, documentation, and why it has to be backed up, everything, I will show you the workflow one document or all the documents go through for the supply of a nuclear power plant. You have on the right side the nuclear power plant with its quality manager, which receives all the components and documentation and checks if everything that he receives is in order, is according to the international regulations, and has to vouch that what he receives and what he will be recommending to introduce inside the power plant is according the required regulations and normatives, etc. This component and documentation, this quality manager receives it from what we call a vendor, one that a company who won, for example, a tender to supply such item to the nuclear power plant. And this vendor normally receives these items from its suppliers. So a supplier, as you might imagine, has a general manager, a director, and underneath their employees, their superiors, employees, different processes from testing to production to quality assurance. etc. There are lots of workers, people like us, who go to work every day, 8 to 5, to do their job in a foundry, in a machining facility, and other kinds of suppliers. So every employee, every superior generates documentation. You have in a foundry, for example, you cast a material, a steel, a something, and then during this process, you have to generate a document, a material certificate, for example, who says how the steel is composed, and lots of parameters and information. So, and this is every process will be doing this. The quality assurance has to create documentation, testify, like validating things that were created. The testing has to do processes, for example, to test that everything is true, but all inside this, for example, this one supplier. Now, all this documentation reaches the general manager or the director or the person in charge to in person responsible for this component. Now, once this general manager receives this documentation, he has to forward it with the component on a ship, on a plane, somehow to the vendor. Now, the vendor receives this hard copy folder, this binder with all the documentation from this initial supplier, and usually this vendor also does some enhancements, some additional processes, and the final component assembled or finalized reaches the nuclear power plant, the quality manager of the nuclear power plant, which receives the component, checks the whole documentation, and if everything is okay, he will give his okay to let it be implemented. Now, this was the case for one supplier. Now, you can also have, normally, you don't have one supplier for a nuclear power plant component, because you have, starting with the foundry, you also already have for at least one more machining, and then there are always other components in the middle. Like say, for example, 3, or we can also have a 4th one, and it gets complex. For example, you can have like 20, 30, 10, 20 suppliers, and it can also reach endure various years. You can have a component done in 1 year, maybe 2 years, or 5 years. It is not something that gets finished quickly. Like, you can also, going back to the heavy size truck you saw, these 4 folders you see there, that's the heavy size truck, just so you get a correlation of size. Now, this documentation the quality manager received is a heavy size truck of documentation, and he believes that the vendor who delivered him this nice looking component and this heavy sized truck full of documentation, that he did everything right, that he filled out everything accordingly, that he did everything according to the international regulations. But like we saw before in the scandalous events happened in the nuclear industry, there can be the possibility that, for example, a vendor, after 5 years of production, receives a nuclear power plant vessel, a huge vessel out of cast iron, which costs millions and millions of dollars, and it could be like it happened in these cases, that, for example, the carbon percentage, for example, in these vessels is not according to normative. So what should one do? One can say, well, it's not according to regulations. I will throw it in the trash, and I will ask the suppliers well, let's do another one, which costs millions of dollars and another 5 years. Or he can say, well, let's take this document which says carbon percentage 0 point something, and let's change this value. And then we'll do a copy paste and edit this document and send it like this to the nuclear power plant. Well, the nuclear power plant has no other option as to accept what he received from the vendor, because the vendor says what is the truth. So
this is the key. I need that you pay special attention about next slide, because we will see the magic of the blockchain applied to the nuclear industry. It's very important.
Well, here you can see our solution, our platform, which is a shift of paradigm, at least for the nuclear industry, where you can see the whole process changed a little bit. Like the supplier still creates documents, the employees of the supplier still create documents, and these documents go to the director and go to the vendor and finally get to the nuclear power plant. But in this case, the employee, when he casts the iron or does the machining or does something, this document immediately the employee uploads it to the blockchain. In the blockchain, like I said before, very simplified, the documentation, once uploaded, cannot be changed. So when the documentation goes along to the suppliers, to the general managers, the quality manager, when he receives everything, he still receives everything from their vendor, but he can take any document he doesn't maybe trust entirely, or a document which is very important for him, and he can check. He can go on a platform and check, well, let's see what the blockchain says. And there he sees that eventually this document was altered, and it will say, no, this is not the exact document which was uploaded by the employee. So there he can verify. He doesn't have to trust blindly in the vendor, but he can guarantee, he can do his job. The quality manager, he can assure that the quality is matched by checking these documents. So now let's see a small demonstration of this platform we talked about. This is our platform, which we are using right now, as said by Santiago, for our fabrication of our seal rings. I will be logging in here into the, yes, I had everything prepared, but as usual in presentations, nothing goes. Please bear with me as I arrive at, you can here see our projects. I will make a little bit tour here, our processes. And for example, here, let's see a document. Here we have a document, which is a steel, a prime material steel, which we are using for the seal rings, which has a date, which when it's supplied, it's a location, which is unfortunately loading. But the important thing here is that when you have to imagine this as a central nuclear power plant, which gets onto our platform and wants to check if the material created, here you can see location, sorry for the delay. You can see it was uploaded here in Villa Martelli in Argentina. Now back to the power plant, which the power plant wants to check if the document is correct. The document, I want to emphasize this, the document which was uploaded by the employee not by his superior, not by the vendor, but by the employee of the foundry. He can check here, well, let's see, this document, great, it's authentic. It does a comparison, which later on we can, if one wants to know, we can talk about. For now, let's go with this, that it checks and knows that it's authentic. And if one alters or forges a document, the platform will say, no, this is not authentic, this is not a document which was uploaded by the employee of the foundry. Well, back to the presentation.
And how about the how about the future?
Yeah, now let's talk about the future. So the next step in Nuclearis for Nuclearis Truck is to like immediately, right now it is open source. You can scan this QR code or later ask me about the web page. It is a GitHub repository which you can download and investigate. And then in a future, we are already thinking about and developing the first steps of a platform generator, which will give the nuclear integrators like vendors and suppliers the possibility to use a intuitive user interface and a no-code development, or like without knowing about development of platforms, you can create your own traceability platform, and we will give it free, so that everyone who wants to do it can do it without paying any money. And here, like the last topping on the whole dessert we served you, we want to create with this presentation the concept, the industry of nuclear tech, where nuclear tech is just like a fintech or prop tech, is the application of advanced technologies like machine learning, IoT, blockchain on top of the nuclear industry. And there are lots of use cases. There are the production of uranium fuel, the waste storage, decommissioning, the safeguard of uranium, which is very critical. So we have also a plethora of use cases which we are eager to apply every possible technology which needs to be applied to.
And we are working on that.
Yes.
At this moment.
And all this nuclear tech, Nuclearis Truck, everything we are doing inside this new industry we want to create nuclear tech is to take care of our planet, to assure the security of nuclear power plants, to improve the wealth of our planet, and to do better, to take care. Well, thank you for your assistance, for your understanding, and if you have any questions, please feel free to ask. I don't know, Francisco, do you want to chime in, or?
Hey there, I was just talking alone right now. I had a little bit of delay. Thank you. Well, thank you very much for the explanation. Here I see a question from Evan. He's asking, what is the objective of the business entity housed in the US? Are there potential clients in the US you're looking at? That's one question.
Okay. Yes, we are looking at the moment with different, well, like we are working in the nuclear industry, so we have some kind to work with the state, because the state is the one who provides all the nuclear components and services. So we are in talks with Sandia Laboratories and Los Alamos Laboratories, which are the laboratory regulation entities in the US, like for at least 2 of them.
Great. Here I have another question from Gloria. Was there any other blockchain implementation use case in the nuclear industry prior to Nuclearis that you are aware of? Or are you setting a whole new record?
We know of some proof of concepts and projects who are working with blockchain. For example, Slavka in Finland, which is doing the uranium safeguard. They developed with a private blockchain, I think Hyperledger. They developed a uranium safeguard platform. And I think in Italy, I heard about a waste storage platform, which tracks the waste who comes out of a nuclear power plant, which has to be controlled also very thoroughly, which gets tracked by blockchain.
Okay, great. Well, here I have one from Sol, also from Brazil. She's listening to us. But I have first. I will ask you one of mine. Do you have any recommendations for or places where we can read about the benefits of nuclear energy? Because as you said before, and as we all know, it has very bad press. But I would like to know where can I learn more about, because it's safe, it's cheaper than a lot of them, and it provides you much more energy than other sources.
Yes, I think one advantage, like Santiago said, is that nuclear energy does not have carbon dioxide emissions. It is good for the environment, and then also the waste is it has waste. Let's not ignore it. Nuclear energy has waste, but it's minimal and it can be controlled if you take the precautions. And also the risk. One always hears about the risk about a nuclear power plant going wrong, and there are so many procedures and mechanical safeguards which doesn't allow a civilian constructed nuclear power plants like here at Tucha 1 and 2 or Embalse and other power plants around the world to go wrong today.
Exactly.
Well,
thank you for that. And here I have the one from Sol that it's for everyone to be aware of. If you can send your contacts, if you can say, well, I left your webpage, but if you have an email to contact everyone, you can say it, and I will write it on the chat box, so it stays for now on for the future, for the one who will be working as demand.
Yes, I'm Sebastian Martinez. My email is .com. And Santiago is S Badran, BADRAN at Nuclearis.com.
Perfect. Thank you so much. I'm sending it right now. Nuclearis.com. Perfect. And Gloria is also, she's typing them. What else? Well, we have another question. Are suppliers likely to be quick to use your document verification application or project? Are there common solutions in places that vendors use?
Regarding the suppliers, like Santiago said, for the first production of these seal rings, we are already using blockchain, and we are working with 2 suppliers who is the materials, the foundry and the machining. And they in the nuclear industry, there is like if you have a purchase order of a great magnitude, the supplier normally always agrees with almost anything, so he can sell you the product. And for example, with our one supplier in Germany and one here in Argentina, they agreed wholeheartedly, no problem at all, to use our platform, so they can supply us with the products. And then the common solutions. I think, for example, here in Argentina, at least, where I can talk about, the common solution is the paper, the physical way. Like you get a paper from Germany via email, via mail, or digital mail, or with a component, and then you create a physical hard copy folder with all the documentation and deliver it with your component. This is the way we also all have to do it, but this is the common way everyone does it. And there is, at least in Argentina, there is no other common solution, a better solution like this one we presented for other vendors.
Okay, great. Well, that gives you an answer, Evan. I don't know if anybody of you are guys that are here on this webinar have a last question. We need to take advantage of having two great experts with us. And if not, well, we can close it, call it for the day. And for the ones who want to listen to the Spanish webinar, we will be live in 3 hours. Okay, Evan says, great, thank you for your answers. And Solange, also great presentation. Gloria, thanks you, Nuclearis team. On behalf of IOB Labs and of course, of RSK, which is part of our family, I would also like to thank you so much for your time, for your explanation, for preparing, and for putting up to us this presentation. And I think that will help a lot of people to know about more technology on a specific case, on a particular complex industry like yours. So,
well, thank you, Francisco, for letting us present this use case, which we worked the last 3 years, and really happy to see it live and to see the interest of you and other participants in this universe.
Okay, great. Thank you, Santiago. Thanks, Sebastian. Bye bye.
Bye bye.
Thank you. Bye bye.